Willkommen, bienvenue, and welcome back to the modding of Isaac with Lyte. And today we're going to be covering entity variants. So taking an entity that already exists and making a slightly different version, while still preserving quite a bit of the inbuilt AI and processing type things. So let's just get started and take a look at what we've got. So our mod this time is dot and dips. Sort of like Dippin' Dots, just poo. And so when we get in here, we've got 9 dips, 4 of which apparently are chasing us around the room. So the regular dips take a couple of hits to kill, as one would expect with base Isaac damage. Just a couple of hits and regular old dips are no more. However, these dips take quite a few extra hits to take out. And then if we give item punching bag, so C281, they do in fact chase after him as well, as one would expect and one would hope. But it's minorly important to keep that in mind, because they won't actually go after punching bag unless you use the correct code for making that happen. So we've got very shiny little dips that chase the player around, and that's what we're going to be working on today. So if we head over here, we're going to make a mod as we always have. You go to your Afterbirth plus mods folder, make a folder for your particular mod. You need main.lua, your resources folder. In here we've got GFX, an anim2 file. We borrowed this one from the regular old dip. We grabbed it, we replaced the sprite sheet with our new sprite sheet, which is here in Monsters, Custom. And here we are, our nice new dip template. But you're like, Lyte, those look like mercury. That's a very shiny little dip. They didn't look anything like that. Well, when you want to make a very intense color that you can change around, you want to make it as desaturated as possible, because then it has an equal amount of each of the colors, such that when you tint it, you get a nice, true, clean color. So when you work with the whites and grays and then tint them red, green, blue, they look great. When you try to tint brown, it causes trouble. And you're tempted to use the offset, but then the blacks stop being true black. So whenever you want a color shift that's this vibrant, for each color you go to, start with white or gray. Okay, so that's our resources. And if you come into content, we have just one file, entities2.xml. Let's take a look at that. This is how you make yourself a new entity variant, and new entities for that matter. You start off entities with the right-facing gator. anim2 root is just where you find the anim2 files, and version equals 5. If this doesn't look exactly like this, it's going to crash your game. Boom. And you always close it with a slash. And you've got everything in between telling it what your entities are. So we make a new entity with the right-facing gator. We close it off, but there's no slash here because we have things inside of the entity itself. The jibs and the preload sound. So there are a lot of things to go over with any given entity that you make. Firstly, the ID number. It has to match the original type of entity you want to be making the variant of. In this case, the dip, which is 217, which is odd because all of the resources reference 216, which is something else entirely. Consistency, people. So there's that problem. You need to keep track of what entities2.xml from the resources thinks is the ID number, which in this case 217, despite 216 being used in all the resources. And there are already several variants. You've got the corn dips and the brownie corn dips. Okay. Next up is the variant, which you'd think would be like the items, where it automatically increments the variant as it sees you need more of them, such that we don't have collisions between mods. Oh well, guess they didn't decide to do that just yet because you have to hard code the variant. It's not good. Hopefully they update it and we'll be able to have auto-incrementing variants. Until then, I would recommend going to random.org and generating a number between 1 and a billion, which makes the likelihood of you choosing a variant that's the same as somebody else's variant for the same monster, it'll be pretty darn low. So random.org, 1 to a billion, go. And we get a number that is unlikely to be anyone else's number, and we don't need to know that number. In the code, we don't need it. We reference everything by name. So when they fix it such that the variant does auto-increment, we'll be golden. We don't even have to change our Lua code. All we have to do is remove the variant, and it'll just work. Until then, hard code it with a big random number. Then we've got a lot of properties here that I have not changed any of, except the base HP and the stage HP, and I haven't even tested what the stage HP does. But this is a formula for how they get their health. I'm assuming that stage HP is how much their health scales as you go along, because as it goes along, they should get more difficult. That's just common game design practice. I make no guarantees as to how this works, but that's how it seems to work. And I'll research it later. But for now, you use this to increase your entity's health. Reroll equals true. You can reroll it using the D, is it 10? I think it's D10. Boss. Bosses are immune to certain things, so you need to identify, is it a boss or not? Champion. Can it be a champion? It's a dip. Of course not. Collision damage, how much it hurts when it touches you. Collision mass, how much oomph it has when it runs into you. Collision radius, how big the collision area is, I guess. Seems pretty small, but that is what it seems to be doing. Friction is how easily it slides around, so it'll slow down more slowly when scooting across the floor. It'll also be knocked back less when you hit it with your tears. Number of grid collision points I haven't had a chance to research, but my uninformed assumption is that this is the squareness versus the circleness of your particular entity. So you start off as a perfect square, and as you add more points, it becomes more circular. Again, I have no proof of this. I will test it later. Shadow size, how big your shadow is. Great. Portrait, have not looked into at all. But I imagine there's a portraits.xml and then there's a number and stuff happens. Or this is your death portrait number when you die. That's probably more likely. Either way, this is a variant. You keep a lot of the same things. But anim2 path, this has to change. This is how yours looks and acts. This anim2 file, I just stole the one for the dips and replaced the sprite map. You can add custom animations if you want. You just want to keep the same names because the animation names are what's triggered by the AI. If you add more, that's fine, but you want to keep the ones that it relies on. And each of the different enemies has different animations. So keep that in mind when making your variants. Bestiary, is it in there? Transform, I haven't tested this to see how that actually works. And animation is which of its animations from here does it play in the book. Jibs, 5 things of poop when it dies. Preload sound, ow. That's how it goes. So this is the entities XML. That is the only XML that you need for this process. No players, no items, no nothing. This is, you're creating the thing. It's the extent of your XML. Hopefully this variant part will change. If you're making a custom entity from scratch, I don't know if it'll auto increment the ID. Haven't done an episode on that. I will let you know when I do. But if you're having trouble with it not auto incrementing it properly and you're getting ID 0 or variant 0, you have to hard code it until they make it work the way it really ought to. Until then, big random numbers. Ooh. And don't think your mind comes up with good random numbers. It doesn't. You got too many 7s. So we've got this. It's good to go. And you save it. Next up is the Lua, because Lua is what makes things work. We're going to go from top to bottom. We'll cover the whole kit and caboodle. As always, we start with mod and game. However, if you didn't watch my PSA, don't attach your functions to mod. Don't do it. When people hold R, they'll get erased out from under you. It's no good. So we make our own. Dots equals an empty table. So just an empty table for holding our functions. We've got our dip variant here. We might make more eventually. But for now, our dip dot is Isaac.get entity variant by name, and the name is dot. So this should seem very familiar for anybody that's seen any of the episodes on working with items, working with tier variant, anything that you make custom from scratch, get something by name, whether it's item ID, entity variant, entity type. It's always by name, and then you give it the name, and it'll return the number. So this is going to return that big random number that we picked, so we don't have to hard code it here. And then I have a local dot chance. This is the probability of a regular dip being turned into a dot. So when we got into that first room, it didn't spawn a handful of regular dips and a handful of dots. I spawned nothing but regular dips. And it pulled a little bait and switch on you. This function right here, the HSV to RGB, I've shown this before. This is for going from hue, saturation, value, and alpha to red, green, blue, and alpha. For this episode, saturation is always 1, value is always 1, alpha is always 1. The hue shifts from 0 to 1, randomly for each dip. The details you don't really need right now. Any web search can give you a nice HSV to RGB function. I'm going to scroll past it really slowly if you want to copy it from here. There we go. So here we've got standard boilerplate for on the first frame, do stuff. It's always post peffect update for me anytime you need something regarding the player. We don't necessarily here, but I have yet to find a particularly good use for plain old post update. If you've got a good reason why this goes in post update or post render or something, please let me know. I would love to learn why you should put things in certain places. It's just so many things require knowledge of the player. I put them in here, just in case. So on the first frame, we have a for loop. Some of you have been a little bit iffy on how for loops work, so I'm going to go through it step by step for you with nested for loops. Nesting is when you take a loop and you put it inside a loop. So you take a little baby bird loop and put it inside a big old nest loop. So this little one is going by faster than the one outside. What I mean by that is here we set x equal to 0 and then do stuff. And then we set y equals to 0, and we spawn in a dip. Well, then we get to the end, and we change y to 1, because what it's doing is going y from 0 to 2 with a step of 1. So if you have 3 numbers, it's from, well, start, end, step. The default is 1. 0, and then it becomes 1, then it becomes 2, and then it runs out of numbers. So now it gets to this end, which takes it back up here and sets x to 1. And then y is 0, spawn. Y is 1, spawn. Y is 2, spawn. Then we run out and we come down here, and now x is 2. So 2, 0, 2, 1, 2, 2. Each of those will spawn a new dip. Now, you don't have to use a step of 1. You can use a step of 0.5. So y would be 0, and then 0.5, and then 1, 1.5, 2. So we would have 5 instead for each pass through. It doesn't even have to be positive. So you could have -1. But you want to start at 2 and then end at 0 because you're counting down. So it would be 2 and then 1 and then 0. In this case, that doesn't matter, but there are other cases where you want to be counting down instead of up. So you might have seen something like this when people are cycling through the enemies list. So entities list. So if you do Isaac.get get room entities, it gives you a table. entities. Well, if you then do for x equals 0, 2, and then not the number 2. If you do this, from 0 to the number of entities, it'll go x equals 0, and then x equals 1, 2, 3, 4, 5, until it gets to the number of entities. And then you'll reference any particular entity as entities, open the bracket, x, and then close the bracket. So it's fairly straightforward on that account. And then this is just an entity. You work with it, you make it do what you want. So that's enough about for loops. Oh, it's almost enough about for loops. There's one other thing that you might want to be keeping track of. How many dips does this spawn? 9. So this counts from 0 to 2. 0, 1, 2. How many times does it do it? 3 times. So 3 times each for x equals 0, and then x equals 1, and then x equals 2. And so what it does is it summons a dip, a variant 0. Just a plain old regular dip. Subtype 0, there are no subtypes of dips. And then at a location, 270 plus 50 times x. So 270, 320, 370. And at a y of 200 plus 50 times y, which is 200, 250, 300. No velocity, no spawner. So it goes through, makes those 9 dips, and all of them are perfectly ordinary. So that's what this entire function does. All it does, first frame of a run, it makes 9 dips in the center of the room. So what makes them fancy? Well, that's this bit right here. So we're using a new callback today, NPC Update. So this is when a non-player character updates. So that's anybody who's somebody who isn't you. Simple as always, mod : at callback, mod callbacks, plural, .mc NPC update, and then .npc update. So I didn't make a lot of hype about that, but we're using dots, which is this table here, instead of mod. So dots, : dots, : but again, you can name it whatever you like. I like using a table such that we don't have an extra worthless argument at the beginning of the declaration here. You'll see other people who will write it as local function, NPC update, and then an underscore, and then the rest of their arguments. Because this is the first argument. This does have something passed to it before the stuff that you want. And this is perfectly reasonable. Then you would come down here, get rid of dots, and you have NPC update. This is fine, it works. I just don't particularly like it. So I use dots dot there, make it non-local. We have it be dots, : and that means we don't need that first argument. That's a preference thing. And then the third thing we pass is a filter. Back in the immortality episode, we used entity type.entityPlayer. Here, we use entity dip because we only want to run this function on dips. We don't want to run it for roundworms. We don't want to run it for monstros. Every time we see a dip do something, that's when we call this function. And so what does it do? Anytime a dip tries to update, so every update frame, we get a dip and we come in here. We set up a local dip data equals dip : get data. We've used this before. It is your own custom table that is attached to that particular dip. Because we're going to need that for any sort of fancy initialization we do. Then, if the type of dip data is table, I don't like that we have to do this, but sometimes this get data does not actually return a table. I don't know the circumstances in which it happens. It happens so randomly and so rarely, I don't know what causes it. But for some reason, sometimes it's not a table. If it's not a table, we'll just let it gracefully fail. and not change that dip. We'll leave them a regular dip. And if for some reason this weird thing happens, I'll look more into that and hopefully we can do away with it entirely. So if it's a table, which it should be, and the dip init part of that table has not been set yet. So dip data dot dip init double equals nil. So uninitialized. And another thing I don't think we should need, but we do, the dip is an active enemy. For some reason, dips that have been removed are reinitialized. I had all sorts of fits with random extra dots being summoned because the dip that I removed to summon them tried to summon another one. What in the world? So if the dip is an active enemy, so they haven't been removed, they haven't been killed, then you initialize them. So if all three of these things are true, they're not initialized, they have a valid data table, and they are in fact an active enemy, then we initialize them. We make them into what they are. So first and foremost, we set their initializer to true. If you don't do this, it'll keep trying to initialize it over and over and over and over and over again. You'll end up getting multicolored, flashing, epilepsy-inducing dots. No good. Always set this. You could set it at the end, but better than, like, sooner is better than later. So we say we have initialized it. Okay, now we actually do it. So if the dip variant is 0, so regular old vanilla dip, not a corn dip, not a brownie dip. Why? Because I just want to change the normal ones. I don't want to change the fancy ones. And you roll a 100-sided die below the dot chance, which is currently 50 for demonstration purposes. I'd probably put it a bit lower. Then you do stuff. So regular dip, they pass the roll, then we do things. Now this is a lot of lines for replacing a dip, but they're necessary. It's actually necessary. Like I have commented here, you could morph the original entity into the new one. You can morph it into the new variant. It's not a problem, unless your new one has more health than the old one. If you have a tanky dip like mine, and you morph it from a normal weakling, the new one will have the same health as the old one. It won't have the new health that we put in the entities 2.xml. That's just no good. We can't upgrade to a tanky dip with the morph function. So we have to invent our own. So what we do is we make a new dip by spawning it exactly where the old dip was. And we force it to be our variant. So we force the variant of the dip. And we set the one that spawned to this variable. We can make that local. It doesn't need to be a global variable. And then we set the color of the dip to a random color. And then 0, 0, false, false, such that it stays that color forever. We've used this color function before, should recognize it by now. And then the new dip, getDataTable.dipInit, is true. So it doesn't come back in here and change its color again. And then we remove the previous dip. We're not killing it, we're just poofing it out of existence. So 4 lines to do what we should be able to do with just 1. Sad, but it's necessary in this case. If your dip still has all the same properties of the old dip, you can just morph it, no problem. So why are we doing this at all? Well, if you just make an entity, it doesn't actually go into the game. You will never find it unless you make it be found. There are 2 main ways of doing that. One would be to make a room that has your variant in it. You can do that with the room editor or the basement renovator. And then you actually have rooms that have your dips in them. But that's a lot of work that I'm not sure you want to do, because you have to add a lot of rooms for them to be able to find your variant at all, and I imagine most of you just want them to be able to run into your variant in the rooms you're accustomed to. So the other option is this one. It's the bait and switch, where it sees an ordinary dip and there's a chance of swapping it out into a new one. Now, this use of randomness is probably not the best, but it's what we're going to use here because you're most likely to understand it. But you should probably seed your randomness to the seed of the run, such that if multiple people play the same seed, they will run into the same enemies. That they won't walk into the same room and have different fights. You want it to be consistent across people playing the same seed. So we'll cover that eventually, but for now, this is what we're going to use for random chance. So we've customized our dip. What else is there? Well, if for some reason you summoned one directly, whether through a room or whatnot, you're going to want to set their color initially. So this isn't the only way they could come into existence. If you made them come into existence via a room type, you still want to set their color properly. This is true whenever you make any sort of thing. You need to think about the various ways it could come into existence and make sure you initialize them appropriately. Then, you're probably going, Lyte, you're running out of lines. You got an awful lot of AI going on there. You don't have much left. Well, all you need is this one line. So if the dip is our dip, and there is a target. So this little bit is kind of important. So if the dip's variant is your variant, and get player target is not nil. So there is a player target. Sometimes it freaks out and doesn't see anybody, you or Punch and Bag or anybody. Nobody. So you need to check this or else it'll freak out. Then you do this one line of code to enable the following. So the dip velocity is, follow along with me here, the dip's player target position. So you or punching bag. It's a vector pointing to where you are. Minus the dip's position. So if the dip were, say, here, and then you were over here, you take this position and subtract this position from it, and you'll get an arrow pointing from the dip to you. That's how vectors generally work. They're arrows pointing. So we'd have 0, 0 up here somewhere. You're here, the dip's here. You take this arrow, subtract it from that arrow, and you end up with the arrow pointing from the dip to the player. If you're not familiar with vectors, you might want to look them up. They have some fancy, interesting properties. But for now, all you need to know is that to get the direction from the dip to the player, you take the player's position and subtract the dip's position. So this here in parentheses is a vector. Then what we do is we normalize it, because we don't care how far the dip is from the player. When you normalize a vector, you keep its direction, but you shrink its length down to 1. So this is another vector, but it's of length 1, pointing from the dip towards the player. Okay, and then we multiply that by the dip's current velocity, but its length. So we want the dip to keep moving the speed it wants to move, because you don't have to implement the AI for the dip being a dip. That's inherited by it being a dip. It's great. That's why you make these variants, is that it inherits the AI of their lineage. Every dip behaves the same way. So it wants to move around randomly. So you get how fast it wants to move. This is just a number. So we have a vector pointing from the dip to the player, and you multiply it by how fast it wants to get there. Now you have to do it in this order. That's why I put this little note here saying not commutative. You can't take this number and multiply it by this vector. If we look in the documentation for vectors, let's zoom in on that. Down here, we've got 4 functions, which are from the vectors meta table. Basically, they define operations. So double underscore add is vector plus vector. Sub is vector minus vector, multiplication, division. Well, multiplication here is vector times number. And it's important because that's the order it has to be done in. It has to be vector times number. There is no meta table that says number times vector. If you try to do it in the other order, you're going to get errors that make no sense to you because you're like, of course I can multiply a number by a vector. But you can't. Not here. You have to take the vector and multiply it by a number. And this is everything it takes to make them track you down in their kind of randomly shuffling dip way. And so you've got all that code for making a very simple change to dips. You just made them a little tougher and you make them chase the player. But it shows you all of the different bits that go into how it all works. So if you wanted to make a completely custom entity or a variant that does very different things, these are all the places that you do it. NPC Update is run all the time and gives you various things that it can do. I'd recommend not just setting the position. If you want to make them teleport to a place, use the velocity instead, because I believe the rendering happens at a faster rate than the updates. So if you set the velocity, it'll move more smoothly. I think that's what caused the jittering in the Rainbow Candle episode. But let's come on back into Isaac and just take another look at how all this works, because you've got a random number of dips every time you refresh, and thankfully, now that we don't attach the functions to the mod object, it never just totally crashes. And most beautifully, when you use punching bag, they will chase after him. But that's all I've got for this episode. I will see you in the next episode of the Modding of Isaac with Lyte.